Okay, hi there again. So let's work in the first tutorial, this one. Okay, we have a nice case. I really enjoy this case. So we will have these cases. You go to your training material 101 Paraview, you go YF17, and then here you have the solution. Okay, we're not going to run anything. So to extract the solution, go like this. So I hope you already know. So okay, X, sorry, I used the wrong command. And we're extracting the solution. So now we go there and we have everything ready to go. Okay, so we're going to post-process this. This wasn't a steady solution. We're going to post-process this last time. Is your goodies you want to run, you have it there, the solution. We're not going to run. So remember what I mentioned, okay, so just to show you something about Parafoam. So if we go to the source code, open Phone 8, and then let's see if I will, no, it will be bin. Here you will have this Parafoam. Okay, this is a script, this is not a program, and this is script, see that is doing this one, calling these operations, whatever. Okay, so it's just a script around Paraview that it will do, it will load filters and create those files. So as you launch Parafoam, you will see that here is creating this temporary file, and that file is the one that is reading to open the case. The other alternative is to do like this. You first create the file manually, touch, and let's say I will call it case phone. Okay, and then you launch Paraview, which is that version without that plugin and those options that kind of slow down everything. So you go here and you open this one, and for large cases you will realize that this is much faster than the Parafoam. Also, you can use Parafoam minus built-in, which is equivalent to Paraview. Okay, so this one, Parafoam minus built-in, is also faster than the Parafoam. So I always recommend you use Parafoam minus built-in. Plus, we have seen that with this option we can post-process the composed cases. Or also, I forgot, you can go like this, Parafoam and the name of the phone, instead of opening that, so directly you are opening. Okay, so you have all these three options. It's up to you which one do you use. So for this case, I will go a small case. I will open Parafoam, there is no problem, but again, everything that I'm going to do, the filters and the operations, they're exactly the same. Doesn't matter what option you use from the terminal. So remember, you press apply, always this button is green, means press me, and you have the geometry. Okay, so here you go down, you will have all the mesh parts, so you can select everything. Then you go out, also you can select everything. So you see by default it doesn't select everything. Parafoam, okay, so you use Paraview built-in, or Paraview will select everything by default. You need to do it manually. So the things are that, for instance, just to show you something, so we have everything. I will create a cut plane, and then I have a cut plane there. Cool, nice. But let's say that in this cut plane also I want to plot the geometry, okay, the airplane, but you see that you cannot access that. It has been already masked by this slide. So I will show you this very important step, okay, just to separate the geometry in different blocks. Okay, one thing that you can open a second case, but that one will load more memory. So here in Parafoam you have filters, okay, filters here, and there are many filters. The specific one that we want to use is extract block. Okay, and here you can extract the different blocks that you have in the geometry. So I want to extract the internal mesh because I want to apply a filter there for cut plane, and then you press again and see that I will apply another filter again, the block. So I will go to resin, extract block. You see that name here, another one. But now in the second one, I want just to extract the surface of the airplane. So I select my surfaces here. Okay, apply, you have here, and see that you have now your airplane. So now here you have this tree structure, and you can apply again filters in different blocks. Okay, so I can extract another filter here, another block, and I will extract now the outer domain. Okay, so I will go here, upstream, lower, downstream side. Okay, so this is the outer domain, is you need it for post-processing, if you want to do whatever. So see that what I'm going to do is that this one, I will put it like outline. Okay, so fix color, okay, and then I will choose black. Then I have here the geometry, so it's being colored now using BTK, not the number of surfaces, but you can put solid color, choose your solid color, and I will choose this one. Okay, you have the geometry. So see that these are different, let's say, entities that you can apply different filters. So now you go here, this is the mesh. Okay, here you have the whole mesh. So in this one, I would like to apply a cut plane. And then you have it. You see that now you are keeping all this one. Instead, if you apply this filter here, you are not able to see, you know, the outer box, everything. Okay, you need to start to separate. So this is very powerful. I highly recommend you just always to use it if you need it. If you don't want it, just apply the filters directly here. But sometimes we want to do like this. So these nice visualizations. So here we have the cut plane. Okay, and then in this cut plane you can go and plot whatever you want. So in this case, reset. So something that can be annoying also that you have this plane that you can move. So you move it here, or you can give the coordinates. So I recommend you always to hide that. So hide it. Also remember that here you have advanced settings. Okay, so if you want to see more settings, just press here. So I always have this option on. So here you have the cut plane. Okay, and then you can move it to give coordinates. For instance, now I want to apply another filter where I want to apply a filter here in this slice. Okay, so you go here, I will apply a threshold, okay, on Mach number, and then you can play this one. So this one will just cut the threshold where the values are given. So I will go like this, higher. Okay, so here now I have a cut plane, and then in this threshold that I'm applying, I just see in the regions where my Mach number is contained between these values, okay? And so on. So you can keep applying filters to filters, or filters to block, or to, okay? So it's up to you. But be careful, remember this data structure, okay? You need to always respect the one, or apply filters to the right blocks, to the right entities. So I think this is the most important part, okay? Something that I was mentioning, okay, you can apply filters. Also, you can change the color palette, okay? So see here that we have, for instance, let me go now in the airplane, and I want to plot the Mach number. No, this is the outer box, sorry. So the Mach number on the airplane surface. And you have the airplane there. Okay, so you have those colors. Some people always, people ask me, why this color? Why don't you have that by default, the rainbow colors? And by default, Paraview, I'm putting these colors, and this has been interesting and something that I also do that analysis. And you will realize in one point that this palette, color palette, it is color insensitive in the sense that if you are color blind, this won't give you problems. You will see all these colors. Instead, if you are colorblind, if you use the rainbow palette, I will show you. So if you go here, edit color map, here you have the different color palettes. So you have the rainbow one, or the jet. Let me apply it here, and now you apply that one just to this field, Mach number, and you can do it. So see that we have different fields with different colors. You can do that with no problem. But just to point out that now this color palette will give you problems. You are colorblind. So that's why by default, Paraview, let's say, is politically correct in the sense that they are thinking about colorblind people. But it's up to you. So you can have your color palette, you can create it, and this is what we're doing, okay? So if I want to save this state, let's say that you have this configuration and you want to reproduce it automatically without doing all these steps, everything. You go here, File, Save State, and you call it, let me call it Test 1. Okay, so you will have that. Let me close here. Here you have it, and then you open this state. If you want to save images, it's here, Save Screenshot. So this is a static image. So you want to save, so you have different formats. So you want to save animations, and in this case we cannot do it because we don't have that data. You have here save animation. However, you can animate cut planes. I'm not going into details there. So we have this cut plane. We can animate it moving. That is something look in the internet, so I don't want to enter in details. So you can animate many things. So if I close here now, And if I launch, and see that now I will launch, I will go touch, case, phone, Paraview, case, phone. So now I'm using another, previously it was Parafoam, now phone. Okay, so I don't want to load this one, I want to load the state. So you go here, load the state, and the state automatically will find this case. This is important, okay? In my case, okay, I know that when I save that state, I am saving that in this, here, I'm saving this one in this directory structure. Now I giving here this location in my hard drive, but you will have a different location. So be careful not to, when you open the case here, you don't select this one, select this one, choose files. And here you will choose the file where you have that case. So you will go here, ellipses, click, and then you just look for this one. And now you are here, you will have your right directory. Okay, so be careful when I'm passing files, these steps, they're pointing to the location in a different computer. So now you need to give your right location. So you just click ellipses and choose the case phone. So you go here and you see that automatically you are reproducing everything. Okay, so see that you are, and see that I open Paraview, previously it was Parafoam, there is no problem. Okay, everything is compatible. Something else, you can have multiple windows. So see that you can open another one, and then you can open another one, and you can close it. So if you want to open this and you want to have a render view like this, you go here, render view, and then you select here what you want to see. So I want to see the airplane, and you see that now these views are different, they are not synchronized. And you can put here different things. So here you can see, you can plot the, let's say, the cut planes, and here you can plot, let's say, the Q criterion, that the vortices. So let me show you. So now I'm going to extract the vortices. I need to extract here because here I know that I have my mesh, I have that information available. So I go here, I choose Q criterion, and I will choose, let's say, 1000. Okay, I would put a number there. Okay, cool, I have it there. But see that I'm visualizing that one here, and see that this blue frame means this is the active view. Okay, so I will hide that one here. I don't want to see it here, and I want to select this one, blue frame, active view. And here I want to see that Q criterion. Then you can change also the colors, or I want to visualize using Mach number, and now you have the Mach number there. Okay, so see that you are using the same color palette that you have here. And if you want, you can split that view, and then you can add another post-processing. So you add this. So it's up to you what you want to see. So it might happen that you are, okay, then let me see that. In my mind, okay, I'm going here. In my mind, air is blue. Okay, so let me put it here, and I will choose blue. I will choose this blue. Well, air and water in my mind, but it's different blues. So I will choose this one. Okay, you have air there, and then you can add also transparency. Okay, so you have your air, I put in the blue, light blue, and then transparency, and these are the vortices. Okay, so see that we have this vortex here in this track, then here there is separation, there is another vortex here, so very nice. Okay, this is actually a nice solution. So remember that those vortices you can change in contours. You can change the isosurface. So I choose 1000. As you put 10, you will capture more information, or less. Sorry, or no more. Okay, so probably this is too much. So let's go 10,000. Probably we're going to see less, better definition. See that. Better. So it's up to you to choose those values. So I would leave it like this. So, but sometimes some people like to synchronize views. So how do we synchronize views? So as you go here, right click, see that you have link camera, press here, and then you press in the view that you want to synchronize. So if you have different views, you select that one. I want to synchronize with this. So now see that they are synchronized. So see, I open a new view. It's this. Okay, it's this. See that only these two views are synchronized. Okay, so you can start to synchronize. If you want to erase that link between the views, you go here, Tools, and you will have Manage Links. Okay, you have the link there, you can remove. And now links has been erased. So here I hope you got the idea of how to plot all these filters. So this is very important, this track one, okay? So you can start to divide and apply different filters, different blocks. Okay, so you select in one block, you put the surfaces, and in the other, the internal mesh, and then the internal mesh, you can apply all these filters, okay? And here, remember, you have many filters, okay? You have all the filters here. So again, just go to the documentation and see what they are doing. I will show you a few of them, okay, but not of them. That will take a whole week, probably more time. So let me close here, and now let me show you, because if you are here, you will see the folder, and usually in all the tutorials, when you see a folder Paraview, it's likely probably that you are going to find states, predefined states. So let's look at these predefined states, what we have. So here I just put in everything, so I will show you a few of them. Remember that you will need to change this location here when you open, okay? So let me go here, and I will use Paraview, and let me use now the other option, Paraview built-in, okay, just to show you the three options. So this one automatically will create this file, whatever. Sorry, is Parafoam built-in. So this one automatically create the case form, whatever. I don't want to load this one because when I open the state, it will be load again. So I don't want to have two files loaded. So you go here, load state, and here in Paraview, you will have all the states. So I will go the first one, extract block, okay? Remember, in your case, you will need to click here, choose file, and then choose the right font. So in this case, this was the one created. This is the one I previously created. And then this one will point to the right location of that file. So let me erase this one that I created. So see that I'm showing you how to create the blocks. What I did previously, you have it here. Okay, so see that a previous state that I created. Okay, so that was that. So let's go to different states, okay, to see what we have, more complicated states. By the way, let's say that I don't erase this one, I leave it there. If I open another state, you will see that we're going to have two files, and that will take more memory. So I will go for the state, for instance, cut plane, and I will go this one, cut plane 1, okay? Remember, in your case, you will go here. In this case, I will ignore because I know I'm in the right location. And see that you have we have the original state, okay, but that one is taking memory. So let me erase. That's why we don't load. So in this state, what we're doing, extract the block, and then you are applying this slice there with the cut plane, okay. So let's open another state. Okay, now the cut plane 2, we have a second one, and to show you how to create multiple cut planes. So you can imagine that it's easy. You can start and just cut plane, cut plane, cut plane, cut plane. But sometimes there is a way to do it. That one can be time consuming. There is a way to do it parametrical. So as you go here, cut plane 2. Okay, well, let me do it so you follow me. Okay, always remember to do that. So you select this one. You are opening, and you are in the right location. So see here that we have 10 cut planes. Okay, reset. Okay, show plane, hide the plane. See that we have, 10 cut planes. Okay, so you can create this manually. You can apply multiple slides to that one, but it can be time consuming. So there is a way to do that one. So if you double click here, you will see that you have this option here that you can add cut planes. Okay, so let me show you again how to do it here. So I will apply this to this block, apply this, and you go here, and you have the option here, and you say I want the cut plane, I know, from -10 to 10. Okay, you should also remember to choose the direction. I will put now 20 cut planes, and automatically will compute everything, and you have your 20 cut planes there. Okay, so in this case, they are normal to X direction. You can choose the normal distance here, how you want it. Okay, here, so normal to X, Y, or Z, or you can give your own plane. So if you have a different plane, you can just, for instance, to show if you have a plane that is like this, just put here now the normal. Okay, so see that very easy. And then now when you do this one, you will have this coupling, and let me put Mach number, and then let me apply. So all these couplings are grouped in a single object here. So you can apply now the threshold. I'll apply a threshold density there, reset, and let me go like this. No, let me reduce. And see that automatically to all those couplings, this filter, okay, where we apply this filter automatically. Okay, we have it there. Okay, so everything is grouped. So this is how you work, okay? If you want to create a single or multiple planes, remember that the tree structure, okay? So here we're applying to the mesh. If you're applying here, will be just to the airplane. Okay, and again, if you want to save the filter, the figure, save a screenshot. So let me close here, and let me move again to another state. Okay, so we have many states. Delete, I don't want it there. Load state, and let's see what we have here. So we have couplings, we see this one. So let's see this one, isosurface. Okay, so here isosurface 1, I already showed you that. Okay, but let's revisit isosurface. Remember, those are surfaces with the same value. Okay, so we have here, and we're not seeing anything here, so I don't know, probably that is an empty one. So let's open the other isosurface. Okay, so always remember to do that. Okay, and I don't see anything here again. Okay, isosurface. Okay, I don't know what I was doing. Okay, so let's move. Okay, yeah, product. So let's go again, Paraview. Okay, delete. So let's move to Paraview. Okay, so for instance, let me move. So for instance, calculator. So here we have calculator. Okay, let me show you what is a calculator. I open calculator 1. And this one will let you compute derived fields. So see what we have here. We have multiple views, as I showed you previously, synchronized. And see here that we have density calculated in Paraview, density calculated in OpenFOAM, and we're comparing the values, okay? So basically to compute, we know this is a compressible case, so see that we have extract blood, we apply the calculator, this is a calculator, we apply it here, and then here you can do your operation. So we use the equation of a state to compute density in Paraview, okay? So we're using the fields, so you do your operations here. So you select the fields, so here you have all the fields available, and you can do the operations. Also you have vectors, okay? And you have here all the operations that you can do here. So here you have, I think this is pretty complete, but you have things more complicated that you can do. You can use a Python calculator, okay? For that, you will need to compile Parafoam or this Paraview in OpenFOAM with Python support, or you can download the binary already precompiled with support for Python. So you have that Python calculator, which is more powerful. What I think, this one is okay. You can do a lot of stuff. So see that here we compute and we compare, and we have the different slides. Okay, so we have one there. See that we have a second slide, normal to y. So let me see again. Let me open another calculator. So let's see what we have in calculator 3. So if we go here, calculator 3, let's see what I was doing there. Okay, so in this case we have the difference. So see that we have. Okay, so what we did here is just compute the difference between density in Paraview and OpenFOAM. Okay, so basically see what we did. Let me show you the steps here. So in this case, okay, we go here, open, apply the first calculator and compute the density in Paraview. Second calculator, it is the difference between density in Paraview and density computed in OpenFOAM, multiply per 100 to obtain the 10 percentage, and the values that you see here is percentage. So 0.6 means 6%, 0.6% difference between this is relative difference. So you see that there is some difference, but not much. Okay, so this is just to show you that, and then you start to do your blocks here. Okay, So this is a nice way, for instance, you have analytical solutions. Usually I do like this, okay, a subtraction and relative error, and you compare your percentage. Okay, so that was that filter. Let's move to another filter, another state. So I go here, load state Paraview, and let me go to gradients. Okay, so here we use a very nice filter called gradients. So remember that we can compute gradients also here. So now here we have the isosurfaces. So see that what we have here in this figure that are synchronized, but these two Q criterion that we're seeing here, they are different. So one corresponds Q criterion computed in OpenFOAM, and the other Q criterion computed in Paraview. So let's see here in the tree structure, okay, in the pipeline browser. So extract block, and then here we have the mesh, and here we apply the filter. This filter is located here, gradient. So this is very powerful, and this basically you compute the gradients of a field. So if you click here, you select the scalar array, important, okay. This one, what it will do, will separate that, okay, so you can do it in T, Mach number, whatever, okay. So usually you compute also the gradients in the interpolated values in here. Here, I don't recommend you to compute it there, okay. So you select your vector, and then you see, you can select this one or deselect. You select, you compute gradients and give it a name. Here you can compute divergence, you can compute vorticity. So see that we're computing here vorticity in Paraview, and you can compare it with the output of OpenFOAM. And here we have the Q criterion. Okay, so see that you have many options. You apply, then you compute that field. This operation might be time consuming, okay, depending on the mesh. So that's why also again it's better to get it from OpenFOAM. But again, if you want, you can do it here. And here you have the contours. Okay, so this one is okay. Here we have, this is Paraview, and this is OpenFOAM. Okay, so we're comparing here OpenFOAM Paraview, and see that pretty much sends to these results. And actually, it looks that it seems to be better in Paraview, nicer. Okay, so and to show you, you see here that you have this surface. So it's pretty much this is also following your mesh. So here is clearly the mesh is tetra. Now you see that structure, but there are ways to smooth that surface. So what, for instance, you want to smooth that surface. For some reason, if you use generate surface filter, you will smooth that one. But this one here, you will see that you have one that is called smooth. This one does not work very well. Okay, it will smooth a polygon, but you will need to do some conversion from tetra. Okay, so if you use this one and you apply here, let's see that. Okay, actually didn't do a nice work, but you see that you see an influence there that, okay, so actually this is mostly the original one, but let's apply that one in Parafoam. Okay, let's see if, so sometimes it will smooth that one, it will make it smoother. Okay, in this case also. Okay, maybe I mean, okay, let me go here and I can go, and I have an option here that I can convert that to bam, 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 bam. So you see that you have many options. You can play with all of them. So in particular, I was looking to surface vector. Triangular street. So one of these will add a triangulation that can make, I don't recall. Okay, probably the next one we're going to see. I don't recall, but probably so you can retriangulate and have a better triangulation. But sometimes when you apply no generate surface normally have the tendency to smooth that. Okay, so this was this case. So now let's move for a streamline. So we already saw in co-processing now how to compute streamlines, but also you can compute streamlines here. So sometimes also actually I prefer to compute streamlines here now because you have the visual reference. So let's say streamlines, let me open, remember that to update the path. I'm not doing it because I already know that this is okay. So see here that you have the airplane, and we have two streamlines released from a location somewhere here. So as I go here, see that it's saying apply that to the mesh. A string tracer, you have the filter here. Okay, so as you go alphabetical, you will have a string tracer. this one. So you have two, so a string tracer, and then you have a string tracer from a given surface. So this one, it will release from a point or a line. Okay, so let's see what we have. A string tracer, and see that here I'm selecting, okay, for instance, in this case, okay, show sphere. Okay, see that I'm releasing here, you have the sphere. I'm releasing from here, from this sphere. Okay, you give the coordinate. You have here the options: high resolution line, so you can have a line, or a point source. You can release from surface. I will show you then later that. So then, for instance, if I go and see here that I'm integrating those string lines in both directions, you can say just forward or backward. Okay, so you can move it there. Okay, so this is how it works. So you have string lines by default are these lines. Okay, they are not very pretty, so it's here that they are pretty lines. So what you do is apply another filter to this one. So this filter is called 2. Again, go here and you will have 2. Okay, the 2 you apply it to the string lines. So see that this you want to do since pretty, and you apply the filter there. Okay, so here you have again many options, normals, whatever, clubbing. So it's up to you to play with those options. Okay, so, and you can apply as many as you like. Okay, so in this case I apply both filters are points, but remember you can use lines. So let's go and choose a line here. Let me use default values. Okay, and there you have the line that it is being released from there. You can move it manually, so let me move it here. Okay, or you can give your coordinates there manually, it's up to you. So I'm doing this. Probably not the optimal way, apply. And then you can also choose the number of lines that you want to release. It's up to you. Okay, so okay, actually it went very well. So see that you have all your string lines there. Okay, so for instance, okay, maximum. So these are integration values. Okay, resolution, so it's probably a little bit too much. 100 points. So it's 100 points along this line. You're releasing those lines. Okay, so this is how you create string lines, basic one. So let's move a little bit more advanced. Okay, in string lines. So I go loop state string lines always. So go here, string line 2, open. Remember to choose the right location. So I will do it just to cement this idea in your brain. Okay, so now it's open, and see that what we have here. Okay, so now we're releasing from this specific surface that you see here, the wing and the other parts of the airplane. So what we're doing here is that extract surface, internal mesh. Okay, but also here we have another surface. Okay, so this is the whole airplane. Let me hide, and then let me hide the string, and then we're releasing just from the wing and the strake. Okay, so here we are releasing. So when you are released from every cell center or node. Okay, so you have the option to choose from cell center or node. So if you have a 1 million cells, surface cells, it will be a lot. So you have the option to do masking to reduce that, which will be the next case that I show you. But how did we release from a source? I will show you. So we're in this state. Okay, I want to release from this surface in my domain. So I use this filter, a string tracer with custom source. Again, you go here, you have here. Okay, so if you select this, it will ask you the following. You go here. Okay, let me redo it again. So I will select this one. Will ask you the input. Where do you want to release? I want to release here. And what is the seed source? From where? I want to release from here. And then apply. This case a little bit time consuming, and off you go. You have it there. So it's colored by BTK. Okay, so different surfaces. So the white surface will be from this region. Okay, so you see there, or you can choose your coordinates, whatever. So this is how this one integration times, you want to compute residence time, okay, you have there. Okay, so let me color by MAC number, and this is it. This is how you do it. Okay, so here you will have again the auctions, everything, but here you are releasing. So for instance, you want to compute vorticity, you need it is apply, so probably will be a faster computation. Okay, so you are computing those, releasing those streamlines from that surface. So you can release from the inlet, outlet, or you can create a source. So let me show you. So for instance, you have this, okay, and I will create here a source. Let me create, let's say a disk. Okay, so see that you have that disk there. Let me move that disk. I don't like it here. Where is that? Okay, let me increase the outer radio. Okay, increase resolution. Okay, so you have a nice disk there, so I can release from there. And so you go again, so you go select filters, string tracer. So you select I want to release in my mesh domain, and the seed input you have, okay, string trace. Okay, I don't have available the disk here. Okay, it's not available, but okay, I will need to map that. But this is the idea: is you have another surface, you will select it and you will release from there. But what if we want to release to reduce the number of stream points there that from where we are releasing? So this is the next case that I want to show you. So we go delete load state, and that one we have it. It will be streamlines 3. Okay, and voila, we have it here. See that now we're releasing from less locations, and actually the location from where we're releasing are these spheres that you see on the surface. Okay, so how do we do this? So let's see the steps here in the tree. So your block, you apply your string tracer, so we're releasing in the domain from this surface. However, here what we're doing, which is important, we're applying, let me show you, a mask. Okay, so see that. Okay, let me go and let me start to hide a few of this. Okay, so originally what is happening here. Okay, now this is it. So we're releasing. Okay, so the steps. Okay, let me go and erase this. Okay, I cannot erase. Okay, I cannot. I don't see where to erase. Okay, so let me show you the steps. So what happened here was we have this block. Okay, so this second is the whole airplane. So we're releasing from here. Okay, and it's selecting everything. So now in this one, from where we're going to release, we apply a mask. Okay, so this is another filter, and see that mask, what it will do, you see this point there, it's just masking there. So if you put here ratio 1, you will see that you will have more points. Okay, ratio 0, you will have all the points there. So a mask, it will choose, okay, it will reduce the point count. Okay, so see that you can randomize here, random, so you have different options here. So special, how to plot that. So generate vertices, single vertices, so play around. But in this case, look at that, we are just releasing from here. So if I increase this count, okay, and now what I did, the next step that you have that I apply a glyph to that one just to visualize those. So when I apply a glyph, the vectors, I select spheres, and see that in this case we're going to release specifically from these locations. Be careful that here you need to, okay, you say all points. Okay, select all points, and see that you have the location. And now you apply your string tracer with custom source. So you select here, and then you select mask point, you release from here. Okay, so this one I cannot modify, but here I'm releasing the domain from the mask points. Okay, and then you have this string lines, and then I apply the tube, and you have the nice tubes there. Okay, so very cool trick. Okay. So feel free, as you see, there are many filters here. So feel free to play with those if you want, but I'm showing you the ones that I use more often. So now let's move to the, let's see what else we have probably. Yeah, second to last. Okay, so let's go Paraview vectors. Okay, so let's plot some vectors. Okay, so I select there. So it's very intuitive, I guess we already know. So here I'm plotting vectors in this cut plane, the one in the symmetry plane. Okay, so see that you have vectors there. So basically they are following the components, and you can apply also colors and everything. So see that the steps. So I created this slice. Oh, actually we're plotting into a slice, okay? And you apply the glyph here. So when you apply glyphs, be careful. So specifically, okay, I want to play with this one. See that you can select whatever you want to use. Okay, so previously I used a sphere, but here arrow will give you the sense. You can also change resolution there. But what is important here, you need to select the orientation array. So here you're putting the vertices in the, let me go here, in the nodes. Okay, is you select here cell center. Okay, I don't want to array to scale. We are putting, see that now in the cell center. Okay, glyph. Okay, you have cell center and also face center there. Okay, so you have the option, but let's put it here in the nodes. Okay, and then orientation. Okay, orientation, let me put orientation like this. Okay, so this is, okay, now this is orientation, and this is how I wanted to scale. Okay, so you want to scale. In this case, I'm not scaling. Okay, so they are uniform. If you put a scaling, it will scale according to that value, and then you give it here an scale factor. Okay. So as you see, things can be a little bit complicated here. But what is interesting here is that here, as you go down, see that here you have this option. You can choose all points, and it will plot all vectors. So if you have, I don't know, 10 million, a couple with 10 million cells there, it will put 10 million vectors. So it can be very heavy, you know, that visualization. So you can choose different options. So uniform spatial, and here you give the maximum numbers or every endpoint. So here you see that it's plotting every 4 or 5 points. Okay, so it's up to you how to do this visualization. Okay, so but be careful with this. Okay, so I think usually by default it is set up like this: uniform spatial distribution 5000. Okay, so here the seed is the random value. Okay, so you put different numbers, different locations. Okay, so usually by default is like this, okay, but you need to play around with that. So this was this basic plane. So for instance, let's see here. So see here, let's see how we are doing the scaling here in this one. That seems to be nicer, those vectors there. Okay, so see here we have where we have the separation, see the vortex, how it's following that. So what we have, see that, okay, orientation array, U in the cell center in this case. No scaling, so these are uniform, and 0.2, and then it's showing you every endpoint. So as I put here all, I will see a lot of vectors. Okay, that was that auction. So let's move to the other auction. Let's see what I did there. So load state, Paraview, vectors, vector 2. Okay, so let's see what I was doing here. Okay, we see that we have more options. Okay, so see here that okay, we have this normal vector here. Okay, this is the previous one. There is nothing new. Okay, but this is interesting. Seeing this coupling, now I have the parallel projection in this one. See that now here I can identify how it is rotating in this projection, okay? And again, you can put a scale in the numbers that you want to see, whatever. But how to do this? Again, you create your slice, okay? So in the slice is where we put the vectors. Then here you have the glyph, the normal vectors, there is no problem. Just so we don't need this step, okay? This is the, but in this slice that you are here, to plot the parallel projection, what you need to do, you have this filter, surface vectors. Go here, filters, and you will have surface vector. Okay, then you apply this one in this slice. So let me go here. Okay, surface vectors will show you the slide, but now it will decompose, okay, the input vector. Okay, so have the input vector and then constraint mode you have here. So parallel, perpendicular, or scale, perpendicular scale. So in our case, parallel. So you have more vectors, you will see the options here. So now that you have that surface vector, you apply the glyph to this one, okay? And now this is the parallel component, just to show you. This is the normal component, okay? So this is the vector normal, okay? You see the actual direction. And in this one is the parallel component, the projection in that plane. And then here we can just get a better idea of the rotation. Okay, see here, rotating, separation, how it's moving. And you can apply that in the other plane, was the same operation, okay? So let's open the search action, which is applying all cut planes, okay? So just to show you that everything is incremental here. So as you have that option with all the cut planes, it will select all of them and then it will apply everything in the same way. So here, see that we have this. Okay, so we created a group here, I think. Okay, here we create this slice here, but we use 10 slices. And then when you select that, basically you apply automatically to all of those sections. Okay, so see, very nice. This is a cool visualization also, I like that one out to see the rotation and everything better. Okay, so let's see, Paraview, what else we have? So we have gone through all. So the final one that I want to show you is ISO volume, okay? So this can be expensive, this visualization, because you are going to visualize the volume using some transparency filters, okay? So if you have a very large domain mesh, it can be something heavy, okay? So be careful of that. I'm giving you the warning. Okay, so here what we have is this, so multiple views, just to show you. And this is what we have. See that we change the color palette, very cool. And see that we have this ISO volume and we're plotting that one. Again, this can be very, very heavy, okay? So here we're using no rendering and graphic video, that is stuff. You need a good video card. If you are using the integrating Intel video cards, this will, I think it will crash. Usually it crash. So how do you do this one? You go here, extract block, and see ISO volume is another filter. You go ISO volume, you have it there. And you select here and you choose what is the what you want to visualize, okay? So okay, that is this. So it shows here Mach number. So get the ISO volume of Mach number values contained between these values. So as you increase here, you will see more. So see that is kind of slow. So probably now it will show me all the domain. Okay, so see that this is and is applying a transfer function, okay, that I will show you where we choose that transfer function. So be careful with this one, that it can give you problems if you don't know how to control that one. Is this where a mesh of, I don't know, 10 million here, it will take like 10 minutes to do this rendering. Okay, now I see that I reduced that ISO. Okay, so this is just, let's say, this is proper CFD, color for directors. So see that you have there. How do you control that transfer function? Let me change a little bit here, 03. Okay, I think this was the initial one. Okay, now, okay, wow, that is small change. Okay, that is the MAC number of the domain. So that transfer function to control is you go here, edit color map is here. So see that you can go here, and according how you choose this color, you will see more or less. Okay, so this is how you control. Okay, so you can go here, add a new point. So to add a new point is double click, I guess. Yes. Okay, and added the new point there. And you choose there what you want to see. Okay, so this you can apply it to different color palettes. So let me choose, for instance, jet, apply, and then you have your jet there. Okay, so you start to add more points, and then you're done. Okay, so you can erase that points with del. Let me erase this one. Okay, so you can, okay, splines, see that you have this control. Okay, so things can get very complex here. Okay, so it's up to you how you want to put this one, but be careful, because this can make it crash your computer very easily. Again, this is not something that you will use most of the time. Okay, so here that probably, yeah, this is for photorealistic rendering or whatever. So I put T there. Okay, probably this one is the hot air, and then the cold one, whatever. Okay, so this was the last option. Okay, let me close. And as you see, things can get very time consuming, very complicated. Also, this highly depends on your mesh. The time here was fast because we are working with a small mesh. I think, yeah, you see that 500,000 cells. If you're working with 10 million cells, this operation starts to become slow. So that's why it's better to do the co-processing, what I showed you previously, that creating those couplings already in OpenFOAM. So, okay, that was this all for this case. That was the state case. The next one will be doing a state. I show you new additional features. Okay, thank you for the attention, and see you next video. Bye.